Hi there, fourth graders. We're going to, this week, be comparing fractions, which is something I know you did in third grade, so we'll do a bit of review of concepts about comparing fractions that you learned in third grade, but we'll also be practicing some other strategies and taking some of those strategies and extending them just a little bit. So before I start the video, go ahead and make sure that you have pencil and paper for notes. Write down the title, Comparing Fractions, and then come on back to the video. So pause now, make sure you have pencil and paper. I don't think you'll need any colors for shading your fractions, but if you want to grab them, you can get them now, just in case. And then come on back. Okay. So we're going to start with the one that I feel like is probably the newest. I don't think this was covered in third grade. And that's that we can compare fractions using what are called benchmark fractions. Benchmarks are used in all kinds of numbers. For example, when you were younger and you were counting money, one of the first types of money that you learned how to count was not fractions, quarters. And so you learned how to skip count by 25s when you were really young. 25, 50, 75, 100, or 25, 50, 75, $1. And you learned how to do that when you were younger. And then you started to, whether you know it or not, compare amounts based on those benchmarks. So you might say, well, 15 cents is less than a quarter because you knew that a quarter was 25 cents. You also do that with just any old whole number, right? Like you can compare numbers based on how close they are to 0 or 10, right? 2 is much less than 8 because 2 is closer to 0 and 8 is closer to 10. So these are benchmarks you've been using for years now. Now we're going to use benchmark fractions, and we're going to specifically right now focus on 0, half, and 1. So thinking about fractions that are equivalent to those and then using them to compare. So we learned in third grade that any fraction is equivalent to 0 if it has a 0 on the top as a numerator. So for example, if I have 0 halves, that means I've got a shape, it's broken into half, but none of it is shaded. Nothing is shaded. If I have 0 fourths, that means I've got a shape. It's broken into fourths, yet none of it is shaded. The numerator is 0. That means it's equivalent to 0. Now, we also learned in third grade, and I know we also reviewed this year, that a fraction is equivalent to 1, so I'm going to jump to the other side of my chart. A fraction is equivalent to 1 if the numerator and the denominator are the same. So that means, for example, I've got 2 halves here. If I've got my shape and I cut it into halves or to 2 equal parts and both of them are shaded, the entire or the whole shape has been shaded. The same thing is true if, let's say, my fraction is 8/8. Both the numerator and the denominator are the same. So if I take my shape and I cut it into 8 equal parts and all of those parts are shaded, the entire or the whole or one whole rectangle is shaded. So when the numerator equals the denominator, we have a fraction equivalent to 1. Now that should be a review for you. Okay, so you also learned in third grade that there are an infinite number of fractions that are equivalent to 1/2. Any fraction is equivalent to 1/2 if the numerator is half of the denominator. If the numerator is 1/2 of the denominator. So for example, 1 is half of 2 because 1 plus 1 equals 2. Another example of that might be 4/8 because 4 plus 4 equals 8. Another way of looking at this sentence that I have right here, I had a teacher say this to me when I was much, much younger. If your numerator is half of your denominator, it's also true that if you double the numerator, it should equal the denominator. So back to that example I had a second ago. Well, I don't think this is the example that I had, but if I double 2, 2 plus 2, it should equal 4. Anytime that's true, where if you add the top to itself and it equals the bottom, it's equivalent to 1/2. So 3 plus 3 equals 6. 4 plus 4 equals 8. 10 plus 10 equals 20. 50 plus 50 equals 100. Anytime you can double the numerator and get the denominator, your fraction is equivalent to 1/2. No, so now you're probably asking, okay, so what? Why does that matter? Well, I can use what I know about fractions equivalent to 0, fractions equivalent to 1/2, and fractions equivalent to 1 to help me compare other fractions. Let me show you what I mean. Let me actually do it this way. So let's say I have two fractions. I've got 2/5 and I have 4/6. Okay? In third grade, we compared fractions that had the same denominator. Right now, they don't have the same denominator. And we'll learn about how to get the same denominator next week. But right now, I can use those benchmark fractions to really help me because I can say what I know about 2/5. I know 2 is less than 1/2 of 5. Because 2's 1/2 of 4, so it must be less than 1/2 of 5. I know that 4 is more than 1/2 of 6. Because 1/2 of 6 is 3. 4 is more than that. So, if this is less than 1/2 and this is more than 1/2, it's greater. Do you see how I compared to 1/2 first? Then that comparison tells me which one's greater or which one's less. Now, the way I did that was that I always compared to 1/2. So it's helpful for me to be able to look at a fraction and say, is that more than 1/2 or less than 1/2? For example, let's say I have, let's do this. Some fractions. Let's say 2/8. I want to decide, is that less than 1/2 or is that more than 1/2? Well, so I'm going to say to myself, hey self, what's 1/2 of 8? Well, 1/2 of 8's 4. So this is less. How about 9/10? So I'm going to say, what is 1/2 of 10? 1/2 of 10 is 5. 9 is more than 5. So it's more than 1/2. How about 8/12? What's 1/2 of 12? 6. This is more than that. Okay, how about 1/4? What's 1/2 of 4? It's 2. Is 1 more or less than 2? It's less. Do you see how I'm saying, what's 1/2 of my denominator? And then comparing the numerator to whatever that is, right? What if I have 5/10? What's 1/2 of 10? It's 5. So this one's actually equal to 1/2. That's exactly 1/2. How about 29/50? What's 1/2 of 50? Well, what's 1/2 of 50 cents? 25 cents. Okay, that's more than 25. So that would be more than 1/2. I'm going to give you some fractions, and I want you to pause the video, and I want you to compare and put them where they would go, and then unpause and check your answers. So here are yours, written in blue. So you're going to compare 8/9, 4/10, 2/6, 9/16, 41/80, and 8/18. So remember, you're going to say, what is half of 10? And then compare that number to the top. So pause now, and then come back and check your work in a minute. Okay, so here's what I came up with. Less than half was 4/10, 2/6, and 8/18. Because half of 10 is 5, 4 is less than that. Half of 6 is 3, 2 is less than that. Half of 18 is 8, and half of 18 is 9, and 8 is less than that. And then over here for more than a half, I had 9/16 because half of 16 is 8, 9's more than that. Half of 80 is 40, and one more is 41, so this is more. And then this one was kind of like a curveball. This was a challenge one. We don't necessarily know what half of 9 is because it's not an even number, and we haven't really talked about decimals yet, but half of 9 is 4.5. So 8/9 is much more than that. Okay, moving on. So now we're going to compare. So I'm going to say 2/3 is more than a half because half of 3 would be 1.5. 5/10 is exactly 1/2. So 2/3 is greater. I can also use the benchmark of how close am I to 0 or 1. For example, 6/7 is really close to 1 whole because 1 whole would be 7/7, right? 1 whole over here would be 5/5. So this is really close. It's only 1 away. This is 3 larger pieces away. So 6/7 would be greater. Now I can also use benchmarks that are greater than 1, like 1.5 or 2.5, so on and so forth. When my whole numbers are exactly the same, I can kind of just ignore them, right? 1/5 is less than 3/8 because it's closer to 0. So 1.5 would be less than 1 3/8. And my last one is 1 3/4 and 1 7/8. That one's a bit harder. They're both kind of one piece away from the next whole. So if I think about it in terms of fraction bars, if I broke something into fourths and shaded it, 1, 2, 3, but then also broke it into eighths, 3/4 is 6/8, right? Because it broke in half, so it kind of doubled the number of pieces. 7/8 would require one more piece, so that one would be greater. So the next part of our video is going to be comparing fractions using number lines, which is a review from last year. So we're going to jump into it. If you're feeling like you need more practice with number lines, that's going to be practice during part 2 of the week. Or part 2 of your lessons this week. But if you need more after that, please let me know because I am happy to work with you if you need it. So you learned when you were much younger that anything further to the right on a number line is always greater, right? It gets greater as you move up the number line or as you move to the right. So you learned in 3rd grade that you can plot fractions on a number line anywhere between any whole numbers. So we're going to start with just 2 fractions, or 2 unit fractions actually, that are between 0 and 1. Now there's a few different ways to plot on a number line, and my preference is actually to use a fraction bar to help me. So what I do is I pick my first fraction, so in this case it's 1/3, and I draw myself kind of a bar that goes between my 2 whole numbers, between 0 and 1, okay? Now I'm going to break it into thirds because my denominator is 3, so I kind of break it 1, 2, 3 parts. And I'm going to shade one of them, and then I can then plot my 1/3 on the number line based on how much I shaded. Then I do the next number line, or the next bar below the number line. And it helps me kind of visualize that visual fraction model to connect it to my number line. So the denominator is 8, so I'm going to break this into 8 equal parts. For me, the easiest way to do that is to break it into 4 equal parts. and then just cut each one of those in half. And that will give me 8 parts. So if I shade in 1/8, that's going to be right here. So based on that, I can see that 1/3 is further to the right. It's further up the number line. Therefore, it is greater. Let's look at another one of those. Again, I'm going to start by drawing myself a box above that goes from whole number to whole number. This helps me understand the fraction that I'm plotting. So I'm going to break my box into 6 equal parts. I'm just eyeballing it the best I can. I'm going to shade 4 of them. And then that will be 4/6. Then I'm going to draw a box for my other fraction that I have to plot. I'm going to break it into 8 equal parts. And I am going to shade 5 of them. 1, 2, 3, 4, 5. Ooh, close. But 4/6 is further to the right. It's closer to 1. So 4/6 is greater. This is my favorite strategy, I guess, for using the number line. I feel like when I was in school, my teachers taught me just to kind of break the number line up. And then once I did that and I, put a number on the number line, then I had to break it up again. Like first I broke it into fourths and now I got to break it into thirds, and it's hard now because I'm adding extra lines, and that felt difficult to me. And then when I got to middle school and I was really struggling with fractions, a middle school teacher taught me this method and it helped me greatly. So I hope it will help you as well. Now the same thing's true if I'm doing fractions that are greater than 1. Both of these fractions are greater than 1. I know they are because the numerator is greater than the denominator. So what that means is now I'm drawing a box between every whole number that I'm breaking into thirds. And then I go ahead and shade 12 of them. 1, 2, 3, that's a hole. 4, 5, 6, that's another hole. 7, 8, 9, that's another hole. 10, 11, 12. So 12/3 is the same thing as 4. Okay, now on the bottom I'm doing the exact same thing, except instead of breaking my boxes or my holes into thirds, I'm breaking them into fourths. And I know I'm breaking them into fourths because my denominator is 4. So now I'm shading 9 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9/4 is like right here. So again, 12/3 is further to the right, therefore it's greater. So I can compare using number lines as a visual. I can also compare using bars. Depending on who you ask, who your teacher is, these can be called fraction bars. These can be called fraction strips. Oopsie. And if you taught in Texas or ever lived in Texas, they're called tape diagrams there. And I don't know why, maybe because they kind of look like little strips of tape, but these are all the exact same thing. No, I don't want to get rid of all of that. Okay, so if you ever hear or see on a piece of work or whatever, fraction strip, fraction bar, or tape diagram, they're all the same thing. Okay, so if I have 2/3, I'm going to break my top bar or strip or tape into thirds. I'm going to shade 2 of them. That represents 2/3. I'm going to take my bottom one, I'm going to break it into fifths, which is harder. I don't know why I chose that. Not too bad. And I'm going to shade 4 of them. And because more shade is greater. So 4/5 is greater than 2/3. I can see it's greater by this much. Okay, this is a review. 7/8. I'm gonna shade this one 7/8. So I gotta break it into eighths because that's my denominator. Denominator tells me how to break that piece up. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, I believe. Shade in 7, 1, 2, 3, 4, 5, 6, 7. Now with this one, I've got to break it into sixths. 1, 2, 3, 4, 5. Okay, 7/8 is more shaded, therefore it is greater. Another way to look at this is that eighths are smaller pieces. Sixths are larger pieces. So you need a larger piece here than you do here to fill it up. That means this one must be more full to begin with. Okay, let's see if I can make this go away because it's in our way. Okay, 6/12 and 10/20. So I'm going to break my top one into 12ths. Why did I pick these numbers, you ask? What a great question, I wonder. Let's see. Nope, not really equal. Okay, that's sixths. So if I cut each one of those, it'll make 12ths. And I'm going to shade in 1, 2, 3, 4, 5, 6. Okay. Now I'm going to come down here and I'm going to break this into 20ths. Again, I'm wondering why did I pick this number? Okay, shading that in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are exactly the same, therefore they're equal. We also learned earlier in this video when we were talking about benchmarks that if I double the top to get the bottom, 6 plus 6 equals 12, 10 plus 10 equals 20, they're both equivalent to 1/2. So I knew that they were equal going in. Maybe that's why I didn't really think too hard about what denominator I was choosing. Okay, so for the last little bit of this video, we're going to practice this together while I show you your slideshow for the week. So let's see how handy I am here with my... There we go. Okay, so I'm going to go back to the beginning. Same directions as last week. There are actually 4 sections this week. I'm glad I caught that. At the end of each section, you can stop for the day or you can keep going. Okay, there's a couple videos linked in. I will link my video here when I'm done recording it. So your first section is on benchmark fractions. So we're going to sort these fractions down here based on whether they are less than 1/2, equal to 1/2, or greater than 1/2. So let's do a couple together. 5/10. I know that if I double 5, I get 10. So that is equal to 1/2. 3/4. Half of 4 is 2. So this is greater. How about 4/10? Half of 10 is 5. So this is less. I'm going to do 2 more and then we're going to move on. Okay, how about 5/12? Half of 12 is 6. 5 is less than 6. Okay, pick one more. I'll do this one too. Half of 12 we just said was 6. 8's more than that. Okay, so you're going to do the rest of them. When you get this assignment tomorrow, these ones should already be done. Maybe, just in case they're not, you should write them down right now, and then it'll be easy already done for you in case it doesn't save. Okay, next one. Now, still benchmark fractions, but using the number line to help me. So where would a third be? A third would be about here, I think, ish. Maybe there. Doesn't have to be perfect. 5/6 is going to be really close to over here. So I know 5/6 is greater than 1/3, or 1/3 is less than 5/6. So I drag the little points up to the number line. I'm not really looking to see if you get them in the exact right spot, just general correct idea. This is the more important part right here. So 5/8 is more than a half. Did you see how I didn't even really try and get it really close? I just made sure it was more than a half. 2/10 is less than a half. So 5/8 is greater. Okay, moving on. Now this time you don't have your number line, so you're just having to think it in your mind. Half of 8 is 4, so this is more than a half. Half of 6 is 3, so this is exactly a half. More than a half, exactly a half. So it must be more. Okay, half of 12 is 6, so this is less than a half. Half of 4 is 2, so this is exactly a half. So less than a half, 1/2. 1/2 would be greater than less than a half. Okay, I'm going to do one more. 5/10 is 1/2. 4/12 is less than a half. Okay, so that's all you're doing for part 1 today after you watched my video. I'm going to do a quick review of the other slides so that you don't have to come back and look again later. So you'll have a quick Khan Academy video to practice tape diagrams just in case. And the directions say that you drag the little colored tape up, use it to shade, and then compare. So 3/4, I already shaded it for you, is greater than 1/2. So I'm going to drag this up, stretch it out to 4/6. Drag this up, stretch it out to 2/3. And I noticed those are equal. Whoopsie, not plus, equal. See how I did that? Drag it up, stretch it out, compare. Moving on. Same thing on this slide. I'm not doing this slide with you because I just did it up there. This time, it's already showing it to you. You just have to write out the fractions. So I'm going to click in the box and backspace. Okay, that one represents 3/4 because there are 3 shaded, 1, 2, 3 out of 4. This one is 1, 2, 3, 4, 5 out of 8. Well, I can see 3/4 is greater than 5/8. Piece of cake. Same thing down here. Drag it up, stretch it out, compare. And then that's the end of day 2, or part 2. If you want to move on, you can, but if you do, make sure you watch the little review. Same thing, fractions with visuals, but these are fractions with pies. If I look here, this is 2 out of 3. This one is 1 out of 3. 2 out of 3 is greater. Okay. Next one, it gives me the fraction, and I just have to pick something that's less. So something less than 6/8. How about 2/8? That would be less. Because something is less when, let me rephrase that. This symbol says that this picture or this fraction is greater than whatever this is over here. It's always open to the greater side. So what I pick over here has to be less. Let's do one more of those. 3/3 is greater than 1/3. Okay. Then another set. review if you need it, then some number lines. First thing you're going to do is plot the numbers. 1, 2, 5/6. 2/6 is less than 5/6. So I dragged the points up and then compared in the circle. I already partitioned these number lines for you. Same thing here, here, here. And then your last page is just to do the same thing, plot, and then instead of using the greater than, less than symbols, you're going to say if this statement is true. So if I have 2/3, that's here, and I have 2/8, that's here. Is 2/3 greater than 2/8? Absolutely not. Got it? That's the end of the required work for the slides. I did put bonus slides at the end for anybody wanting more practice, because there were some of you last week who wanted more practice. These ones are optional. You don't have to do them. If you don't want to do them, you can just close out of here right now and go back and make sure you hit turn in the Google Classroom. That is all, my nuggets. So you have this assignment, and then on part 5 is just a quick kind of Google form quick quiz for the end of the week. So it's these slides and a quick quiz. That's it for the week. Remember to email me if you need any help with anything. I miss you bunches and bunches, and I will either see you in a small group this week or I will see you Friday in the whole grade Zoom. Goodbye, happy fractions!